We want to find out if the strength of the synthetic fiber is affected by the percentage of cotton in that fiber for percentages of 15, 25, and 35%. We have tensile strengths in pounds per square inch for some different samples of fabric with those different cotton percentages. And if you look at the previous video, you can find the sums of squares that are provided here. What we want to know then is, using a level of 5%, is there a difference in the population mean tensile strengths for the percentages of cotton? And we always want to provide an ANOVA table when we're doing an ANOVA problem. So let's write out what we're actually going to want to test for. Our null hypothesis in ANOVA is that all the means are equal. We've got three groups, so our null is that mu1 is equal to mu2 equal mu3. I'm going to write out in words what this means, and this is saying that the population mean tensile strength is the same for all three cotton percentages. The alternative hypothesis then is that it's not the same for all three, which doesn't mean they all have to be different, but just at least two of those means would have to be different. So we write this as at least two of, and we list out our means. We've got three of them. At least two of these differ. Now we want to fill out our ANOVA table. I've got that set up here, and I've put in the sums of squares we were provided. The next thing to find are the degrees of freedom. The degrees of freedom between is k minus 1, where k is the number of groups. We have three groups, so k minus 1 will give us 2. The degrees of freedom within is n minus k, where n is the total amount of data. If you look, we have 13 total observations, so if we take 13 for a number of observations minus 3 for a number of groups, we get 10. If we add 2 and 10, we get 12, and that should be equal to our n minus 1, so 13 minus 1. Mean squares are obtained by taking your sums of squares divided by your degrees of freedom. So within the table, you take 256.086 divided by 2, and you'll get 128.043. If you take 80.836 divided by 10, you'll get 8.0836. And now our F-test statistic is a ratio of those mean squares. So F is equal to the mean square between divided by the mean square within. And so we're going to divide 128.043 by 8.0836, and that'll give us 15.84. So we want to look for this test statistic, 15.84, in our table, our F table, where we have degrees of freedom numerator of 2 and degrees of freedom denominator of 10. So going into our table, looking for 2 as our numerator degrees of freedom up here on the top, and then 10 on the side, what we're going to find is this list of numbers. So we have 5 values, and so we're looking in this list right here, 2 and 10. The biggest number we have in the table is 14.91. Our number, 15.84, is off the table, if we think about this being put vertically. And so the tail area for 14.91 is 0.001. Our p-value, since our number is even farther out in the tail, our right tail area is even smaller than 0.001. So we end up with a p-value that is less than 0.001. So with this small p-value being less than 0.001, it's obviously going to be less than our significance level of 5%. So we are going to reject the null, which means that we have significant evidence that the population mean tensile strengths differ for at least 2 of the cotton percentages. The ANOVA tells us we do have some differences. It doesn't tell us which ones are different. There are further procedures that can be used to do that, but we're not going to talk about those here. So all we know is that for these three groups, the population mean would be different for at least 2 of those percentages of cotton.